I'm going to make several videos here for examples for the statistics stuff. This is example 1.4, obviously from Shigley's from the beginning of the book. And so we have a shipment of 250 connecting rods with a mean tensile strength of 45 KSI, a standard deviation of 5. Assuming a normal distribution, how many rods can be expected to have a strength less than 39.5 KSI, and how many are expected to have a strength between 39.5 and 59.5 now KSI? And the idea here is that we want to try to get used to using the tables in the back, the table A10. So graphically, what this looks like is we have a standard deviation in here, or a standard distribution, I should say. And the first question is, how many are below, how many are going to have a strength less than 39.5, right? So if this was like, just essentially right here, we could say that this was 39.5 right here, whereas this is 45. And what we could do, what we're really doing is we're going to look up at a table and find what this area is, and then we're going to multiply it by the 250. That's the big idea. So the first thing that we need to do is to convert our situation right here, where we have 45 and 5, to convert, and then we have a particular number right here, and convert that into a z function, right? This is z right here, z, and that expression looks like this right here, right? And then whatever we happen to be looking at right here, we could just subscript x right there. That's the thing that we're dealing with, right? So here's the actual number, here's the average, and here is the standard deviation, right? So we're normalizing this. 39.5, so you subtract out the average, and then you divide by the standard deviation, so that's 5. So what you end up with is a negative 1.100. Now what that's done is it's really kind of like centered all of this data onto a common mean, right? So let's say like is graphically, like we have like some crazy thing here where that's 45 and this is data that we found out, but on our little tiny standard deviation, we made this so this thing is just going to be an area of total area of 1, right? And 0 is the mean, right? So we've shifted the thing over to an average, right? So we would moved it over to what the average was, and then we divided through, we scaled the thing down, right? So we shifted and scaled in order to make it so that we can use this deviation thing. So it's best to actually use it through the book and go to table A10, and someone's texting me, I don't know who that is. And look in through there, and I think I have all kinds of marks and stuff on mine. So let's see. I want to try to find where z, coming down to there, is equal to 1.1. And let's see, I gotta move this a little bit. I'll raise this up a little bit higher. That's not the right one. Raise this up a little higher. Out a little bit further. A little bit further. So I can't leave it over here. Okay. So if we take a look at 1.1, right? It doesn't matter if it's negative or positive. That's really just it makes it to the left or to the right. It's over to it's over to that side. It's over to that side. So 1.1, we get a probability that's this thing right here, right? That's what all this stuff is. I don't know, is that iota? What is that symbol? I forget. As a function of the ZA, right? So 1.1 is 1.357, right? And we would subtract this from 1 if we were going to do it from the other direction, right? So, but here, so that what that really saying is 13.57%, right? So that ends up being like the area underneath this one little piece right here. So coming back to this, we say that the Z, and that A, by the way, that's the 39.5 is what they ended up sticking that in there. So 0.1357. And what we want to do is the number of rods is going to be 250 times this. So that's 33.9. So therefore, the answer, approximately 34 rods expected below, to be below 39.5 KSI in strength. Okay? And now it asks us, say, how many are expected to be between 39.5 and 59.5, right? So there's 45 right here. So somewhere over here is our 59.5. So what we want to do is let's find the Z. That's going to be for 59.5, and that ends up being 59.5 minus 45 divided by 5, right? Because we're using this equation again. And we get 2.900, right? And now we look up 2.900. So we have 2.9, and that's easy enough. We don't need to do the interpolation up above. Like, here's all the decimal places, right? So in fact, like if it was 2.95, what we would do is we'd add 2.9, and then we would come down to here, and that's 0.05. So this would be 2.905 right here, right? But right here, we just need this guy right here because it's underneath this column with 0. So 0.00187. So 1.87 is going to be percent. It's going to be greater than, right? Because that's good. You know, just taking a look at our little graph right here, it makes sense, right? So what we end up finding is the I of our 059.5. Looking up at the tables, right? But now we want to use 1 minus this. I didn't mean I meant that guy. Whatever that's supposed to be. Is that iota? I gotta look that up. And so so what we end up finding is 1 minus this Z 59.5. And it ends up being 0.9981. So 99.81% are going to be, does that seem right? Yeah, okay, yeah, that's okay. 99.81 are going to be would be less than, excuse me, right? So that would be over this area down over here. But now we need the difference between these two. All we need to do is subtract them out in this range, right? So the probability, a lot of times we'll use P for probability, it's going to be the 0.9981 minus our 1357, so that's 0.8624, so 86.24%, and therefore, let's say, I guess I put it up here, the rods are going to be 250 total of them. 0.8624 is going to be equal to 215.6 rods. So let's say approximately 216 rods, almost office hours, are between 39.5 and 59.5 KSI. And there you go. It's not too terribly bad. You just want to use the examples as a means of trying to keep track of this kind of thing. nifty document that high onto the thing. But it did, I guess it did for the book. So anyway, another one down. I'll make these as separate videos. So.